So we have a nice straightforward little experiment today. You're going to be combining 8 solutions and see if you form any precipitates. The way solubility rules work is any time ions run into each other in solution that want to form a crystal, they latch onto each other and form precipitates. So in this lab, that's what you're going to do. You're going to combine different solutions and see which form precipitates. Then, given the ions that are present in the solution, there'll be 2 cations and 2 anions present in each of the solutions. You have to decide what cation and what anion are forming that compound, that is the one that is actually the precipitate, and which ions in that solution are the spectator ions, the ones that aren't doing anything. To get started on the experiment, you're going to have to download the lab sheet, and then you're going to have to fill in a grid, like the following. This grid lists the compounds across the top and down the side. And as you combine the 2 solutions, you'll have to mark in the space where they match on the grid what you observed, whether they're precipitates, what color if possible for the precipitates, and any other information you can put into that square to fill your data. So, let's get started with the experiment and begin combining the solutions.
This is what our 6 solutions originally look like. The potassium chloride, the copper chloride, the potassium chromate, the sodium chromate, the silver sulfate, the copper sulfate, the silver acetate, and the sodium acetate. We're now going to proceed to mix those solutions together with the other solutions. So we have our 8 solutions. We will now add the sodium acetate to each of the other 7 solutions, stir them together, and see what happens. And so there's the result of our 6 solution of the sodium acetate added to the other 7 solutions. So now we've combined all the solutions in that row on our table. Now I have to go down to the next row and combine the solutions in the next row on our table. And so now we're on to our next solution, the silver acetate, and we'll combine it with our 6 remaining solutions and see what happens. And so there's our result for the silver acetate with the remaining 6 solutions. So now we've combined all the solutions in that row on our table. Now I have to go down to the next row and combine the solutions in the next row on our table. We'll now add copper sulfate to our 6 remaining solutions. Stir them together and see what happens. And there's the result of the copper sulfate with our 5 remaining solutions. So now we've combined all the solutions in that row on our table. Now I have to go down to the next row and combine the solutions in the next row on our table. We'll now add silver sulfate to the remaining solutions and see what happens. And there's our results for the silver sulfate solution. So now we've combined all the solutions in that row on our table. Now I have to go down to the next row and combine the solutions in the next row on our table. We'll now add sodium chromate to the remaining solutions, stir them together and see what happens. And there's the result from our silver chromate solutions. You can't see. So now we've combined all the solutions in that row on our table. Now I have to go down to the next row and combine the solutions in the next row on our table. We'll now combine the potassium chromate with our remaining 2 solutions and see what happens. And there's our result. So now we've combined all the solutions in that row on our table. Now I have to go down to the next row and combine the solutions in the next row on our table. And finally, we'll combine our last two solutions together. And there is our result. And so that's the final pair of our solutions. We've now tried all the solutions in pairs, and we need to decide if there were precipitates. The way you can tell you have a precipitate is if the test tube became opaque, that is, you couldn't see through it anymore. The colored solutions are transparent, as are all the clear solutions. You can see through them. If you can't see through it, that means it's a solid and you have a precipitate. So you need to mark the ones where you got precipitates and figure out what ions are in those solutions. Then you have to figure out what ions are in the solution, have to be in the solution in order to get that precipitate formed. We formed several different precipitates, but the fact is we've formed the same precipitates many times because the same combination of ions showed up in each solution. So you have to figure out what pair of ions, what cation and anion, had to be in the solution together to get that particular precipitate to form. Now, if you've recorded the appearance of the precipitates, that'll help you out, although you have to be careful, because several of the solutions are colored. And if you get a white precipitate in a blue solution, then this precipitate looks blue. So you do have to be kind of careful about judging what color the precipitates were if the solutions are in fact already colored. So the first question is how many different precipitates did you actually get? That is, how many different compounds did you form? Not how many times did you get a precipitate. You got a precipitate a lot of times, but there were only a few actual compounds being formed because the same ions showed up in many of the solutions, and anytime they ran into each other, you got those precipitates. So the first question is, what ions were present in every solution where you got a particular precipitate? And then you have to deduce what the formula of that precipitate is based on the cation and anion that were always in the solutions that gave that precipitate. Okay, and that's the end of the experiment. Have a nice day.